All right, we're live. We're live. What's up? Okay, what we got today? Etly Preact signals. The heck? GitHub down again? Jeez, what happened to GitHub? You got too many backups. A new kind of distributed hunting kites. Weird Al had 100 gigabytes of RAM. Huh. Slow news day. Jeez. Let's see now. Show Hacker News. Simulate dollar cost averaging in any mix of stocks. Okay, let's see what we got. Oh. In the past... Okay, if you're biased towards the past 5 years, come on, man. Let's see. If you dollar cost average into Apple, you get 131% past 5 years. Yeah. That makes sense. What about SPY? Let's see if you versus SPY, you would have had 24%. Interesting. Okay. This is gonna be interesting times, actually. Let's see. What happens if you leveraged into like some meme stocks? GME. If you dollar cost average 519%. Okay. Hey Justin, what's up? All right. Is GitHub down? Partial cloud out? Oh yeah. Okay, I promise you guys the video is coming. I plan to release it by the end of the week. I just have like 2 or 3 more animations done. But basically it's a video on what's called debugging under uncertainty. It's basically gonna be the story, and just to give like you guys a preview, it's basically gonna be the story of me trying to submit my pull request here. So let's see. Actually, how's it doing? Yeah. So this pull request I got going, I think it's pretty much dead. It's in limbo, but oh wait, hold up. What the heck? My video. Oh wait, I just realized it didn't notify people of the stream. Give me a sec, guys. Yeah. So it should be coming out by the end of the week. So let me go ahead and mess it. Yeah, so basically it's this what's it called? This diff that I made. I'm pretty sure it's dead though, because based on the comments that this guy made, this is the Google maintainer, right? There's a few but yeah, like he has this comment here, but the bottom line is that it looks reasonably good, but they have a better way of actually handling the situation. But I think that the whole exercise of me going through all this and actually putting up this request and the logic behind the code here, because it's really just 8 files changed, but fundamentally the idea is like very simple. It's actually not that bad. It's really just this integer override. Let me see if I can move it, but yeah, it's basically just this integer override. And so it'll be the logic it takes to go and kind of look at this multi-million line code base and submit a diff for a very nuanced piece of code. So I think it'll be one of my better videos. I put a lot of effort in editing it, so hopefully you guys get a chance to watch it. But I'm thinking it'll be out by like Thursday or Friday. We'll see what happens. In the meantime, while we're waiting for what's it called waiting for people, I guess kind of simulate it. Call it like whatever you guys want for like a dollar cost averaging simulator. I think this is actually very interesting. Okay, if you dollar cost average in Airbnb 5 years ago, you would have done that. Actually, hold up. One of my best plays was actually. Wait, what? Wait, you can't actually pick every single. Oh, it only does the S&P 500, I think. Because I was gonna do Amcom distribution. Yeah, I think these are all just the ones that are in the S&P 500. Oh, Seneca Foods, okay. Bro, what the hell is this? Okay, so it's actually can't. It won't actually get the It won't get like micro caps. I think it was like it just crashed on the micro caps, which is kind of funny. All right, whatever. Let's see what else we got. Uh, yeah, guys, if you guys want me to do like any finance stuff, like I won't actually do like the the Graham Stephan or whatever Meet Kevin style videos. It's more like I'll just go over into like the 10Ks that might be interesting for you guys for like tech companies, and I'll just like list out what I see is like risk factors and stuff, how I would value the company. I think just being able to look at the businesses that you might be working for and knowing how to value them is a supremely useful skill. And I don't mind doing examples, but I would definitely like for people who are requesting this to actually um, show me what kind of valuation work that they've done before in the past, or at least try to look at it at the company. Ooh, shipping rates. But yeah, if you're going to work for like let's say Airbnb, it's very useful to understand what's going on underneath the hood of the business and not just like what is happening in the news cycle. Because there's a difference between getting the information and knowing how to think about it. And if you look at the fundamentals, it doesn't matter what information happens like today or tomorrow or whatever. Like this ocean shipping rates have plunged 60% this year. What mostly happens is that you should be able to look at this long-term compounding machine. Like, let's say Apple, for some reason, enters into a scandal where, like, say their VP of sales was doing insider trading or something like that, right? Now that's gonna be like a management problem, a little bit, but for the most part, Apple still very much relies on sales of iPhones, sales of services, and so on and so forth. So the fundamentals of business are still going to be sound no matter what you see in the news cycle. So it's really important that I think if you're going to be like a product engineer or like think about business in general, you're going to need to actually understand how these businesses operate. And the best way to do it isn't like through word of mouth or what the recruiters say. It's almost always in the SEC filings. Wait, why did my Wall Street Journal crash? So I'd really encourage you guys to actually try to um, make some effort to learn this on your own. Again, I don't mind talking a little bit about it, but I want to be very very hesitant about doing financial stuff because I'm not a financial expert and I don't want to be held liable for what other people like. If you decide to invest in it, I don't want to be in that position where I have to say, oh yeah, not financial expert or whatever. But I'll tell you what I see. That's it. I'll tell you like what are the red flags, but I'm not gonna tell you what to do with your money or your job offer. Check the logs. I don't want to bust. We have like 1 minute left. I don't really want to bust open the what's it called, the logs or the server side scripts or whatever. The reason why is because like it's just too much effort. Okay, but either way, the reason why I popped this one open, shipping rates are plus 6% this year. Basically think of transport and infrastructure along those lines as super cyclicals. So like for instance, let's say trucking, right? In trucking, you have like the suppliers, and then you have the freight, right? Suppliers would be like your WalMarts, and freights would be like your drivers. Now, people will bid on the rates at which they will ship goods across the country, and so this encourages people. Like when rates are low, people will get out of the industry, and when rates are high, people will immediately follow and get back into the industry and bid up. So you actually have this like cycle of what's it called of prices. At basically it's a boom and bust, right? And the rough cycle for trucking is like 3 years, right? And shipping is pretty much the exact same thing. You have super cycles. The thing that makes this interesting is that the cycle has very much been delayed because of logistic issues. Like earlier, I think last year, they had a bunch of ships that were stuck at port because they couldn't get offload their goods. And now that everyone's offloaded their goods, there's a glut of supply. And I think Target in their last guidance said, yeah, we have too much stuff, so we're not going to order new stuff. So if they're not going to order new stuff, they're not going to ship stuff over. If they're not going to order, because they don't order stuff, shipped, stuff doesn't get made. Stuff doesn't get made, stuff doesn't get shipped. So this is basically why I would say why the shipping rates have plunged 6% this year. So which means that ocean freights will basically take a huge hit eventually in like 6 months. Because oh yeah, the rates have plunged, so they're gonna be oversupply of people shipping stuff, and so they won't make as much money on each transport, and so you can basically expect like a lot of shipping stocks to take a hit. At least that's what I understand. But let's see how well that plays out. I'm usually not wrong about these things, if at least based on my understanding. So I'm pretty confident. All right, let's bring on my client and see what's up. Let's bring out his. All right, he looks like he's in the waiting room. Okay, cool. Yo, hello? Huh, his mic's not connected, so let's wait a little bit, guys. Oh, there you go. Hello?
Hey, Albert.
Yeah, I can hear you.
All right. How's the quality, by the way?
That's fine. I got you. It's a little choppy, but I think we can make do.
Okay. Yeah, if this does not work, I can call in to the Zoom phone numbers.
Okay, got it. Because it's saying your bandwidth is low, so there might be some interruptions.
Okay.
All right, cool. Yeah, catch me up on everything. We did the replay analysis last week. Kind of how has your practice been over the weekend? And can you show me your practice diary?
Yeah. So let me see. Let me paste it on the chat here. Yeah. So over the weekend, I went over the replays that we did for Tuesdays and Thursdays. And I also went with the theme to start with the user, and I also kept the checklist of the questions I asked. For example, how can we be more efficient? How can we basically upgrade the experience for the user? Questions like that. Like for example, if you're putting data into a database, it's not good to have a column that's taking up too much space as opposed to others. So there's basically non-uniformity there.
Okay, I'm a little bit confused on that, but I'm sure we will go over like some problems so you can explain a little bit further. But if you like start to pick out these little details, I think that's going to be a good sign. But ultimately, we want to harden your approach and questions. So, do you have a copy of your approach so far?
Yes. Let me see. Oh. So if you open up the diary, it's on the first row, the column on the far right.
Column on the far right.
Let me see.
Okay.
Sorry. Oh crap! What happened to it? Okay, so let me paste it in here. It looks like it didn't get saved.
Okay, so question to ask. So you have a little bit here, right? Questions to ask yourself. Do you have an overall like general approach in general?
Yes.
Okay.
Yeah. Let me paste this in here.
Sure.
Yep. So I just pasted it there.
Cell which one? I2 or?
Let me see. L3.
L3. Okay. Okay. Cool. Let's see what you got so far. I'm gonna paste it in the, what's it called? The prep doc. Let's see what you got. Okay. How can it be more efficient? What are the new interruptions? Okay. See, strand the system. Load balancer. What do you got? System. Homogeneous single responsibility principle. Server 1 write, read.
Yeah, like that one, I took it from like the Instagram prompt. Like, rather than having one service to do both the view images and the upload images, they separate out. So it only does one thing.
Okay, I understand. Um, I see. There might have been something that, there might have been a little bit of screw up. So when I said checklist, I mean if I am going to do an approach a problem, there's like certain questions and engines I'm going to use, right? Go back, like, so for instance, if I'm stuck trying to figure out what the next thing I worry on, I'm going to go back to the user story and expectations, right? Other times I'm going to be like, hey, yeah, this is like, if I am going to, I don't know, think about, let's say, some caching mechanism. These are the questions I'm going to ask myself. What you have, on the other hand, is really like um, is more like a collection of facts. That's the difference. Let me see if I can explain a little bit better. So let's say I'm a doctor, right? And I'm going to go into surgery. I don't want notes on when to use a scalpel versus, like, say, a knife or like a hacksaw or something like that. What I want is a checklist of step-by-steps of questions and things I need to ask myself when I'm doing something. So for instance, let's say I'm going into surgery, right? I need to sign my name on the part of the body that I'm going to operate on. I need to make sure my equipment is going to be sterilized. How do I know my equipment is sterilized? Because I need to put the tools in a plastic bag and then with a sticker, and then that sticker reacts to UV light to know that, it's been treated with UV rays. But you see, like, how what I just described is a step-by-step recipe and formula that generalizes the approach.
Right. Right.
And what you're doing is generalizing a bunch of facts. And the reason why this is significant is because if you start memorizing facts, you then just end up blaming the answer on, oh yeah, if I only memorized this one fact, I would have gotten the problem right. That's not that way we want to think about it. The way you want to think about it is, if I had asked this question for myself, then I would have been more likely to get the right answer, or I would have been more likely to consider X problem area. So let's go back to your thing. So after an action, can I be more efficient, smarter? That's not a bad question to ask. I think this is going to be one of your key engines in your checklist. That's fine. What would this new interaction interact with? That's fine. But I want you to, like, start taking these questions and ordering them. So things like, if it's too hard, too difficult, that's great. That's a great heuristic to have. But then the sharding thing, this is where I'm starting to have problems, right? Say partition on user ID, no servers, user unequal follow, multiple shards on photos. This is basically you memorizing facts. This is what I'm talking about. So in other words, you want to generalize this more into a question of, like, hey, when do I shard by what? How do I choose which dimension to shard by?
Okay.
So you want to be able to have listed as, like, a conversation, as a recipe, as a, these are the questions I need to ask myself in order to know what to do next.
Okay.
And implicit in that is the understanding of facts. You don't want to memorize facts. You want to have at least some intuition of what these facts entail. It's a very subtle difference, but it's a very big one.
Okay.
So with that out of the way, I want you to at least try to reorganize it a little bit more, given what I just said. It's hard. Again, it's hard for me to describe, and I don't want to give you, like, my checklist. But again, it's like the step-by-step thing of how you do things. So.
Yeah. So the doctor analogy is a really good one. So I think here I mix, like, a bunch of heuristics and facts there. So
right.
Let's separate these out. Okay.
In other words, let's say another way to think about it, and I'm giving you a bunch of heuristics by which to test this, because everyone's checklist is going to be different based on their experience. But another way you can think about it is, like, if you gave that checklist to a competent individual who doesn't exactly have the best memory, could they do reasonably well?
Okay.
The reason why I say that is because, hey, yeah, if I handed it to, like, another L5 engineer and said, hey, approach this problem like this, they could reasonably come up with the same answer as you, instead of, like, whereas if you just said, hey, these are 10,000 facts, and you handed that to them, chances are they wouldn't be able to come up with a good answer. They just know 10,000 facts.
Yeah.
So, all right, let's look at each of the problems that you did.
Okay.
So let's look at the okay. So I think we looked at tinyURL last time. No, we looked at what's it called?
Pastebin.
Pastebin last time. So give me the top two you want me to look at, the ones that you feel like, hey, yeah, I did really well on, or you didn't do well on.
So like the Instagram, let's look at the Instagram one, because with that one I introduced a bunch of load balancers.
Okay.
But then in the answer key, they really simplified it. For example, they have a service to upload photos, and then they have a service to view photos. So this one really threw me off there.
I see. Okay, interesting. So let's see your notes. Let me pull up the Instagram one. Give me a second. And this is okay. Okay, so let me actually look at your approach first. Let me see if it's reasonable at all. So join the channel. What's the thing you need to add? Design Instagram. Users should be able to upload photos, public or private. View timelines. Okay, search on photo tiles. User can follow other users. Newsfeed as top. Okay. Non-functional requirements, highly available. Latency of system is 200 million. Okay, sure. Can give a consistency for availability. Okay to show photo later on. Highly reliable. Cannot lose media uploads. Okay, that's fine. System will be under heavy load, high traffic, 100 reads to writes. 40,000. Okay, this is all perfectly reasonable. But I would also suggest that you add explicitly the cap theorem in there as well. I think that's, from what I've seen from people, that's almost always like one of the better ways to handle these things.
Okay.
Only because it gives people a very explicit check to do, right? And like I mentioned before, it's like, oh yeah, because you very explicitly ask for a cap theorem, and then because you already choose partitioning in a scaled system, then you must choose between C and A.
Mm-hmm.
So you pick high availability and eventual consistency implicit in this. At least that's you basically say that, but I would just want to make that check part of the check explicit. Does that make sense?
Yeah. So I had a quick question on these function requirements and non-functional. When I'm doing these problems, should I come up with these or just get them off the system design grokking?
I would say do your best to get as much as you can. And then when you're doing the problem, let's say you thought of every single possible requirement and expectation that Grokking might think of, or what you think is reasonable. Then you go to Grokking and see, hey, functional requirements, did I hit all of them? And if I did, this is why. If I didn't, this is why. That's what you're going to review on your replay.
Okay.
But for now, to make progress in the problem, just make sure you're solving the right problem. You would want to eventually copy, just like use what Grokking did, and then take a look later on when you go to review the problem. Does that make sense?
Okay. Yeah, that makes sense. Yeah.
Okay, so first things first. Let's take a look at what you did here. You came with the application server, you search and newsfeed. That's fine. So if I had to guess, you came up with the newsfeed service first.
Let me see.
Or did you try solving both of them at once?
If you look down on the notes, those are in sequential how I added them. I'm trying to look where I added that. Search service is number 3. Search service is number 3. Yeah, number 2 would be the newsfeed service.
Okay. So what can go? What's efficient about database? Do I need timestamp object store? Or else can go wrong. Let's visit once and draw the diagram. Okay, I need to view timelines. I have a logic in the app where it will look at every user we follow, and grab the top post from their table. Okay.
That's what you're wrong from the database, actually, from the table.
What is inefficient? A user will be able to follow many people, and this will be a choke point for the database. Okay, yeah, that's fine. Grab top post from the table. Complex many queries to introduce simplicity. Separate the logic out. A service that can return the top post of a user that user 1 follows. Okay, so basically you're talking about aggregating a newsfeed.
Correct. Yeah.
Okay, that's fine. I have no problem with that. All right, so it's inefficient because you're going to be hitting the database many times with the aggregation. That is perfectly acceptable. Yes, I understand what you're doing. I think that what you're talking about is fine as a pain point. No problem. Okay, next one. So then now, what is it efficient? Use the following choke point database. Why not introduce caching? Yep. We can populate most popular posts and victim LRU. Yes. Most recent about no one cared about unseen posts. We can afford to take the hit if go database is not found. Okay. There is a question. So what's your caching policy? Is a caching policy LRU on a user basis or overall? Here, because keep in mind, it's not just the individual users you need to think about, right? You have to think about every other user. So I like bringing up the Kanye problem, which is if Kanye posts, right, and which he did over the weekend, right? Everyone is looking at Kanye, like,
yeah.
Shit, that motherfucker can post like anything, and and obviously that's something you're gonna want in the cache, right? But let's say a normal user doesn't follow Kanye, and then he has and you use the LRU possibility, right? Then there'll be a bunch of users that aren't very popular that will live in the cache.
Mm-hmm.
That doesn't seem right.
Okay. Okay.
So in other words, you would want to be a little bit more explicit in like what the real problem is.
Okay.
It might be a problem for the individual user. Yes, yes, I agree. You do need some LRU cache, but you want to specify the policy a little bit better.
Okay.
So in other words, I think going by LRU cache, you want to explicitly state what the problem is. It's not just oh yeah top posts of a user, but what might the user base in general expect.
Mm-hmm. Mm-hmm.
And of course, like if it's too hard or too difficult to figure out, you can always like just start with the individual users, right?
Okay.
That's fine. So yeah, okay, that's fine. Search service, interested in mapping of keywords. Okay, wait. The question is ask cache for database in one central source. I decided to keep a cache for both the database and objects since we'll separate responsibility, not jam too many things in one cache. Okay,
With this one, what I noticed in Grokking, they have a cache in front of in front of each in front of one database and then in front of one object storage. So the question there is like, does it make sense to have two separate databases or just one where you can mix everything?
wait.
So my reasoning for that was why not have it in just one go, right?
Okay, I'm looking at it. Which section are you on? 8? Because I'm looking at the Grokking system design.
It's for Instagram. Let me see. Where is that? Let me pull it up. Let's see. It's loading.
Okay, let me look at the overall thing you did here. Okay.
Yeah. 13. Sorry. It says we can introduce cache for metadata service, cache hot database rows, and then it also says.
Okay, so you can introduce a caching for hot database rows. Okay. Yes, that's the Kanye problem we talked about. We can use a mem cache to cache the data. Application servers, before hitting the database, can quickly check if cache has desired rows. LRU, reasonable cache eviction policy. Yep. I think that's right. Yeah, I think LRU cache is fine, but you also want to consider the most popular users as well. So what you did was you for now I'm gonna say that's fine, right? Oh yeah. They have a section intelligent cache. Yeah. Okay. I see. So you're right. You did the LRU cache. And the Grokking does agree with you. That's fine. And then I jumped ahead. It's like, okay, well, LRU has this problem, and then you have the 80-20 imbalance, which is a Kanye problem. So you're right. You just need to take that the next step. So that's at least you got the first step.
Okay. Cool.
So I want you to write that down in your checklist. It's like, okay, now that you have the naive solution, which is the LRU cache, is there a bigger problem out here once we start aggregating things? It's like to think about the next step. So
okay.
Again, not bad for your first attempt, but if we can, this is like going to the next step, so it's fine. All right. In other words, let's look at this thing now. Newsfeed generation service. You got the cache, object store. Okay. So something I did notice in the what's it called? In the what's it called? The solution. You have a cache and you have an object store. The problem is that they also have a metadata. Do you know why this is relevant?
Yeah, this was going back to the old problem that we did. You want to separate. You want to make it more. You don't want you want an efficiency in your database, right? Because not all objects are going to be the same, right? You can have 1 KB or 1 megabyte ranging all over the place. So why not separate that out into like an object store and just have a pointer from the relational?
Not a bad answer. That's really not bad. You're right. Some of these items we may want to have like a thumbnail for because in case users are on low latency. But let's say we didn't jump that far ahead to the optimization. The thing is that with these image stores, right? They're literally just images on a disk, right? And so you just really want the URL at which they exist, and that's what the metadata is going to be.
Okay.
So it's like, okay, I have a high-res version of this image located at var user, XYZ123, right? And they have a low version of that at XYZ123 slash thumbnail or something like that, right? So effectively, what you're really doing when you think about it and you apply the single responsibility principle is that this object store really just holds images. Now you could do like why don't we just put it in a database? In which case I would ask you, why would we want to put it in a database with a like a MongoDB document key value store? But because then now you have to start thinking about how to key each one of the photos. And, now we invoke the two hard heuristic. Oh shit, how do I do this keying thing? How do I know which photo belongs to who, and how do I know I'm getting the right one? So, all roads lead to Rome when we think about single responsibility principle plus two hard. So this is like something I would critique if I was you in the practice diary. Does that make sense?
Okay. Yep.
Next, relational database. I understand what you're trying to do here. This is like the posts themselves. They will have a blob URL, and so your object store effectively is that, right?
Right. Yeah.
So it will. So I get the point here, but I would definitely still have it as like image metadata, and then have the relational database here for the post. Hit the image metadata, and that would get you a little bit more consistent.
Okay. So
go ahead.
Okay. Yeah. Makes sense. Okay. So you said it would bring you more consistency for having a separate image metadata.
It makes it a lot easier. It's really just, again, single responsibility principle plus it's too fucking hard to use a MongoDB. That's at least my mentality going in.
Yeah, and with that one you can have like the thumbnail, the high res image, right? That's what you're going with there.
I'm saying that is a natural progression. And I maybe I shouldn't have said that because my mind naturally went there. Because if you think about the optimization, but let's kill the optimization. Let's suppose that you didn't think that far ahead. All we have to really think about is, okay, bunch of users are uploading, bunch of users are downloading the image, right? In other words, we want to be able to make sure that this, whatever we're using to store the images, whether it's a image store or document, doesn't run into a lot of issues when we have high volume of traffic going to it. And my instinct is that if we use a database, we need to make sure that if we're using a database to maintain these images and whatnot, and the schema, that we get more benefits than we pay. In this case, because you've already explicitly stated that we're gonna have 101 read-writes throughput, we're gonna need some form of replication for this storage, and plus we're gonna be reading a lot from it, right? So having a document, having like a what's it called? A database doesn't seem quite right to me, because we're constantly gonna be locking it. It's like, it's just too hard to think about, right? It's like, how are we going to manage the locking of each row? Do we need to lock each row when we do a bunch of reads? What happens if we update the image and someone deletes it? It's just like you start having to consider a lot of different problems when all you really want is just the image at this particular location.
Right.
So you start seeing, like, if we start pulling back the curtain and pulling that thread, it's like, it gets too hard. Let's not go down there. Let's try something simple. And the simplest version is literally just, hey, get image at this URL. So that's where, like, if I just had like an image metadata where it's the key value or whatever, that'll be fine. So, and then you also get the benefit of fast replication, because all you're doing with like a CDN is really just replicating those images, copy paste all over the globe. So that's the way I would.
Yeah. Okay, that makes perfect sense. After I did this farm, I thought of the CDNs, and from what I read is they basically bring assets to the user based on their region, right?
Yes.
Like if you have a user in like the Philippines, there's going to be a cache that will serve them. So how do you decide how to go that far, right? Like, do you want to introduce like CDN for these images? Or is that the wrong approach I'm taking here?
I would say if it varies based on what you specified in the functional versus non-functional requirements. So let's say Instagram, right? A lot of the let's say we've reached the point where we need to consider super users and whatever, right? If we consider that most of the traffic comes from super users who are international, so the number of people from, let's say, Russia and versus Canada, they all roughly hit the super users or super people like Kanye at roughly the same rates, then CDN is not necessarily going to matter as much. Now, if we instead say, hey, yeah, it's local or whatever. Well, actually, no, let me take that back. So if we say that these celebrities are localized, right? Then
Okay.
we don't care about propagating a photo from a U.S. based influencer or person to Russia and vice versa, because most people are going to be accessing that U.S. based influencer from the U.S. So we can keep that localized. On the other hand, if let's say a bunch of people from Russia are accessing US based people, then okay, well maybe we want to replicate that data from the US into Russia. That's where CDN consistency comes in.
Okay.
So,
Okay.
in other words,
Okay.
if we think about like a CDN, all it means is I'm taking data from location A, moving it, and making a copy to location B. In order for, and what's the benefit and drawback? The benefit is I don't have to be a user on the other side of the world making a ping and get request halfway around the world. By making this copy to a local area, I save a bunch of users that trip. Does that make sense?
Okay. Yeah, that's good. Good. Cool, man. Yep.
So that's the way you should think about the CDN. But I usually only
Cool.
things like load balancers and CDNs I look at after the fact, only because
Okay,
I want to
okay.
solve the core problem, and then once I have the core problem down, I can at least start putting like the solving things with inefficiencies like with the load balancers and stuff. So, okay.
Okay. Okay.
After that, the search service I don't really care about, but yeah, looking at everything I talked about, let's actually see what you did wrong. Let's see what you did
Okay.
with your
Okay.
shot delta. So let's look at row 5 here, right?
Okay.
Yeah, simple design, no mention. Okay, so let's look at what you did right, what you did wrong. So I'm gonna paste that in the prep doc just for my own viewing. Drove this is wrong. So this is wrong. Okay, so let's look at that.
Oh, yeah. So one thing about my diary, like one column is gonna have the delta, and then right below there, I wrote questions to ask myself. So it helps me better remember how to approach it later in the future.
Fine, I'm perfectly okay with that.
Instead of having,
Go ahead.
Instead of having a separate column for that. So.
I have no problem with that. Again, whatever helps you figure it out the best and organize it the best, that's up to you. All I ask is that you have it in some form or fashion. Okay, so let's go to the questions to ask self, right? Wait, what the heck? Why is it blank? Oh, I think it's blank for the row that you gave it to me. Yeah, it looks like it's blank. Alright, it's fine. I'll let you fill it in afterwards. Let's take a look at what you wrote here. So.
Okay, yeah. So those are inside the delta. So I wrote down the delta, and then afterwards I wrote the questions to ask.
Okay, that's fair. Simple design. You drove user functional requirement, non-functional requirements. Fine. No mention of growing our system really, really fast. I don't understand what this means.
So what that means is like in Grokking they got into like sharding.
Yes.
For example, they mentioned like sharding based on user ID. And then they say the drawbacks of that, and then they go on. Okay, let's go ahead and shard based on photo ID.
Yes.
And using consistent hashing, you can have a distributed database load.
Okay. So in other words, you.
Yeah. So that.
Go ahead.
Yeah, I basically totally missed or didn't think about sharding here or scaling the database.
Okay, so that's gonna be the question you're gonna ask yourself. Like, is there going to be a problem with the photos and databases that we have? So that's gonna be something you're gonna add, right? Okay. Next, approach load balancer cache. Answer high level questions. What is the simplest use case? Okay, so this is the load balancer that you were talking about. Okay, so then.
Right.
I would say that I don't think it was very relevant to the problem until the end. Let's see. So this is. Generally, CDN. I think honestly, CDN would have just been fine, because you don't need to like you can put load balancer in front of the server if it's like homogeneous and whatnot. But yeah, I would say that if you spent a lot of time focusing on load balancer, I think that's a mistake.
Okay.
So I would say you do it at the end. At least that's what I would take away from this, because they don't give very much focus to it either. If you look at it, it's just like, oh, our service would have some caching, right? We would need some cache here, but they don't actually go into load balancing at all. That's the thing.
Right.
So I think it's a mistake to make that a focal point if you did. So that's something I would definitely want to pay attention to. Like, why is it that I had load balancers but the system didn't? Maybe it wasn't like actually a problem. All right, next thing. One thing and one thing only. Okay, so read write into two separate things. Yes, good, good. This. I like this. I like the fact that you caught on to this. Do one thing and one thing only. I like that. Didn't go much deal. Retard data store. How can we keep the data forever if this is the route we need when you consider large IDs or currencies? Okay, sure. So okay, so in other words, when you go into regards to the data store, this is where you want to look at the section of DDIA.
Okay.
At the replication in DDIA. It's like chapter 9 or something. And so this is where you really want to be able to get used to it and get used to the ideas that they present. So in other words, let's look at the what's called replication here. Yeah, reliability and redundancy. So losing file is not an option because this is a very high priority thing. You want to make sure that, hey, how do we make sure that our databases handle this right? So it's a natural question that you want to ask yourself. And because you didn't, it didn't seem like you actually did. So in other words, you want to be able to dive into this based on the functional and non-functional requirements. Okay. So the thing you want to do is yeah. So you kind of already have it. Like, how do you enforce that not losing data, essentially? If it's important, why didn't you address it? So maybe it's something maybe it's just ignorance, in which case read the section of DDIA.
Yeah.
Which I'm starting. Okay, we had this discussion. As we grow, multiple partitions reach for database, so when it's time, move over partition to single server. I don't understand this.
What I meant by that is, this is just a point to talk about, like, you can have a disk and have multiple partitions on it, right? You can have multiple servers running, and each will be saved in each partition. So as you grow out your system, you can move out a partition in a database to a separate server as you grow your system.
Oh, I see. Okay, that's fine. It's basically what you're describing is just like, as the system grows, this is how our sharding policy might go from simple to complex. I have no problem with that as a discussion point. I actually have no problem with that. And I think it's very intelligent what you just did. But ultimately, that should be a stepping stone. It shouldn't be like the main thing, because because eventually the interviewer will say, yeah, that's all great and all, but we have 2 billion users or something, right? So this is not bad as a way to get there, but that should not be your final answer.
Okay.
So no mention of ranking service generation. Question asked how user get feed data. Push pull hybrid, yes. Custom newsfeed, pre-generate, yes. Because you if we look back at your functional versus non-functional requirements, you explicitly call out, hey, we want some news generation service, right? So it seems like that should be a natural part of what you got going, which is the newsfeed service, yeah? So all you really handled so far when I look at this is the photos, and barely that. So now you have to fulfill the contract of your functional versus non-functional requirements. And, it's like, oh yeah, make sure I check off all the things that are vital here. So, to me, that says, hey, you did the first step of the functional and non-functional requirements. Now you just need to follow through. So, in other words, follow through on your functional requirements and NFR. So that's going to be so if I were you, I would put that as part of your checklist. If I'm done with the problem, then I need to make sure that I finished my functional and non-functional requirements. And so that's going to be part of your checklist. So, okay. A21.
A quick question on that. In their final design, it doesn't look like they listed out those services. What do you think of that approach there? I'm sure they talk about it later, but they didn't necessarily draw it out in the diagram. Is that fine?
The thing is that if you notice there, they said take a look at designing Facebook's newsfeed as a That's what you dive into, and you can kind of hand wave it a little bit because, like you said, it's like designing Instagram. All we really care about is just the ability to look at photos and upload photos. That's essentially what we're looking at, right? And the newsfeed generation service is on top of that. Let's say tomorrow Instagram decided, you know what? We don't care about the newsfeed. We're gonna do it like, what's a good example? Shit. We're gonna just kill the newsfeed, right? It's hard to imagine that, but let's say we kill the newsfeed, and instead had something like, hey, you're only gonna look at, you're only gonna be able to search for your friends' photos instead, and we're not gonna recommend photos to you. Very difficult world to imagine, but just play along, right? That would not be remiss of the core Instagram service, because ultimately Instagram is just we want to look at photos. We want to upload
Right.
photos, we want to download photos. And that's going to be part of your functional versus non-functional requirements. How simple do you want it to be? And what are the core features versus not the core features?
Mhm.
Again, I would say because of how core newsfeed is to Instagram, it's not a mistake to consider it part of the core thing you do need to think about. But before you even have a newsfeed service, you need to make sure your photos even work
Mhm.
and are
Right.
bulletproof. So
That's like one of the last. You would add that later. That from what I'm getting at.
right,
Yeah,
you just think about the chain of dependencies. Does newsfeed depend on photos working? Yes. Does photos depend on newsfeed working? No. So therefore, you're going to dedicate all your time to design the photo, upload, download, and whatever.
Mhm.
So you just think about what's dependent on what, and what that will get you to what's important. And then, again, that's another thing you should probably write down in your approach.
Yep.
So okay.
Okay.
So again, not bad for a first start, but definitely there's some details you missed out and can be better. But I do see a little bit of improvement already. Did you feel that?
Yeah, for sure, man. Driving off the users, that kind of like basically flow ideas into my mind as opposed to just like saying, I want to add this server here, I want to add this service. So yeah.
Yeah. So let me write that down at the top. I'm gonna. If there's anything you get out today, is what is the most important thing, and how do we get there?
Okay.
So in other words, that depends the exercise I just did. The whole we have the users, the Kanye problem. That's another one. And because that will definitely get you there. Because again, you did the LRU, which is the first step. But the most important problem is when we actually start thinking about the system in general and the users in general. Okay.
Mm-hmm.
So with that, we can do what I can look at the Dropbox one if you feel like it's worth, or if you feel like I'm not going to repeat myself, then we can look at the Dropbox one. Otherwise, we can go straight to a problem.
Sure. Yeah. It would help looking at the Dropbox.
Okay, that's fine. Because if you feel like it's the same mistakes, then there's no point in doing it. But if it's not the same mistakes, then yeah, we can do it. So let's look at it. So Excalidraw. Okay, let's see what you got going here. Functional versus non-functional requirements. Upload, download any device, sure. Cap theorem. Yeah, you call out the explicit cap theorem. Nice. Synchronization between devices, update, fine. Upload, ACID transactions. Okay. Why do you call out ACID? Let me ask that. It may or may not be a mistake, but I'm very curious.
Yeah, man. So going back to the question I asked you earlier, I came up with this. Looking at the Grokking.
Yes. But why? Why do you want to call out ACID specifically? And why didn't you call it out in the other problem?
For this one, since we're treating this as like a file system, and you're expecting it to have your data all the time, right? When you're looking at the cap theorem, you want your data right away with consistency. So that was my idea there, and I just went with it. Because my idea was like, okay, you want to upload your file and you want to make sure it got added there, and you want it right away and fast as possible.
Sure, that's not a bad way to think about it, but you sacrificed availability. Every request should receive a non-error response if you accept availability. In other words, you basically rejected that. So my question is, why did you pick one or the other? If you assume consistency, then you assume acidity, which is perfectly reasonable. But my question is, why did you want to give up availability? Now, again, this is like not right or wrong. I'm just curious what your reasoning is.
Yeah, basically, my whole thought on that is like, okay, yeah, I kind of like thought of like a bank system where your transaction, or sorry, like you're running something against the database, and if it fails, it will not insert anything. If you raise an exception, for example, so you would have to retry. So if I have a file and I chunk it up in pieces, you're gonna send it over and save it to your database. Mm-hmm. But if something fails, you would have to try that request again.
Okay, that's for uploads. Okay, that's not again not a bad answer. What about downloads? If I'm on the other side of the, let's say I'm working on a collaborative workspace, right? And my person is uploading the files, right? Eventually, they will eventually see all clients will see the same view of the file even right after update or delete, right? But then I need to be able to find the replica of the file as well. So the upload guy is gonna be fine, but the download guy might be kind of fucked. So.
Yeah, I see your point there. I didn't consider this one, so yeah, that's a good.
Again, it's not wrong, right? Because based on cap theorem, we're gonna have to pick one or the other.
Mm-hmm.
So my question is just like I want you to have the right reasoning for it. That's it. That's really it.
Okay.
So another way to think about
so
it.
I guess.
Go ahead.
So I guess I would ask myself in the future, looking at all the use cases, is this what you want? Consistency or availability? And then I would think about uploading and downloading.
So if we think about consistent, like we have CPU, right? That means that there's going to be a risk of some data becoming unavailable. But if we have AP, that means that we might read inconsistent data. So which one would we rather have? Would we rather risk some data becoming unavailable, or would we rather want users to read inconsistent data? Which one is the one preferable one? Let's ask that.
Okay, so if you read inconsistent data, there could be something in your service that tells you whether the file is ready or not.
Okay.
So I'm looking at from that point of view.
Okay. I mean, I think let me clear up your answer, but I think you're on the right track. Is that if we have some level of versioning with the files, eventually we will get the right version. So even if I like read some fucked up file, there's gonna be like some hash or like some version of like, oh, this is the version 10 of the file, and you download version 9. We're gonna update your sync because now that we have everything validated, then we can update you. That's not necessarily a bad way to think about it either. So it's like it's just again, when you come to the system design, you're making these trade-offs, right? In this way, what I would think about is what is the least sucky one, and I think as long as you can fall back on like some level of versioning, I think you would definitely want to pick CP. So.
Okay.
So what you did is not wrong. It's just you need to have the right reasoning for it.
The right argument. Okay.
Yeah. So it's like convince me, make it sell itself, right? So, all right, let's keep going. So you have no data loss, durable, no data loss. Yeah, you don't want to lose files, correct? But you might lose files. You might lose a chunk of the file on the upload just by nature of uploading. So.
Yeah, I should have been more explicit there. Like, once your data is in the database, it's going to be there forever, basically.
It's fine, because I mean, part of it is like what I just said was a stupid thing as well. Because everyone loses chunks of files on upload, right? So that could be just me, like just kind of like, oh, this is the first thing that came to my mind. But something I did notice is that you didn't have anything related to versioning. Why?
Let's see. Yeah, let me see. I'm looking at the notes below. Yeah, that's missing for sure.
Yeah, when I look at this, I'm like, well, the user who's using Dropbox, if I upload another version of the file, can I get back an old version?
Right.
And
so yeah, here in where I have my pointer, it says It says we will have a client running in the client side that will monitor file changes. We can have a diff and only upload those changed chunks. So yeah, I totally missed it in the requirements above. So I talked about it later. So let me write that down.
Another angle to think about it is that because the whole discussion I just had with CAP, like CP versus AP, the only reason we would be able to accept CP versus AP is because we have some level of versioning that can say, hey, this user downloaded version 9 and now we have version 10 available. Maybe they're still reading version 9 for whatever reason, maybe it didn't propagate or whatever, but eventually they would get version 10.
Okay.
It's just something like that. If you think of it from like multiple angles, then you might be able to come up with something different. It's like all roads lead to Rome. There's another way that you could have thought about it, so maybe you ought to at least be able to decide in your checklist when to choose CP versus AP. Okay. Of course, like when you explicitly call out the CAP theorem, then that will naturally lead to that discussion. So. Okay, so but again, your asset is not wrong if you chose that. So okay, Next thing, estimate users. You have a bunch of petabytes worth of data. Fine. Yeah, capacity estimations, whatever. Device files. Okay, so now you're gonna start using the Okay, I'm gonna read. Let me read what you wrote down. Okay.
Okay.
Oh, you have second. Oh, you have 2 attempts at this. What the heck?
Yeah. I tried this one Monday, I believe, or Sunday. Then I tried again today.
Okay, I gotcha. Okay, with a simple idea, I can view data from every device. The data will be uploaded, downloaded to each device, and efficient. Let's introduce an upload service that'll chunk the file, either upload in case of service. Okay, the upload service I think is on the client side, and that's the thing. I don't think in the system design we really do we care, because I think we're mostly just focused on backend. So I would say this is probably not relevant.
Yeah, in the actual answer key, they do have it in the client side. This one.
Yeah, so I mean it's fine. It's fine to call it all out, but it's not something that should ever be focused. So okay, if they do it in the solution, that's fine. I understand what you're saying, and I don't have a problem with that. File metadata want to separate logic from database and keep a file metadata database. There's a chunk information or files, fine. Yeah, because you're gonna have the original file in like an object store probably. The thing about the metadata is that okay, you have a summary of the file, but then you actually need the file itself. No.
Yeah, correct.
All right. So wait a minute. Should I be looking at the left one or the right one? I noticed you have two.
Oh yeah. This one on the right. Oh, let me see. This one on the right. That's a answer key. One of the answers in the solution.
Okay.
So I was just using this when I was writing down my deltas.
Got it. No problem. Okay, that's fine. Okay, so based on the file metadata, want to separate logic from the database and keep a file metadata database. Okay, that means that you need to write out that you have a file metadata, and then you also need to have the actual files themselves. So you need to have two object stores. So I would expect to see like an object storage database and a metadata database. At least that's what I would expect to have in your diagram. Okay.
Okay.
Next thing, user will be able to update data, sync across clients. Yeah, that's fine. Monitor file changes. You can have a diff and upload those changes to change chunks. All those files are uploaded. We can set it to complete sync. Okay. Do they actually talk about the client side of these things in the answer?
Yeah, they do.
Okay, that's fine. This is I think what you did here is fine. Your answer is very reasonable. And I don't think in an actual interview they will ask you to go any deeper than this. So
Okay. Yeah.
I think it's fine.
So that's another thing that threw me off. Yeah. I thought about it, but I didn't go into it. So yeah, that was my mistake there.
It's not bad. It's more like okay. Let's play this with me, right? If I'm the interviewer, what's the next logical question I'm going to ask if you say this?
Okay. Can you describe that in high level? The sync service basically on the user side.
You already kind of described that. You said you have the sync service, which is like, oh yeah, you're going to have a watch for when a file changes, and then upload the diff whenever the file changes.
Okay. Yeah.
So my question to you is, what's the follow
up? The follow up I would take is have a box for each of these. No, hold on. Yeah, because I'm thinking of the answer what they have, and they basically have another diagram, and it says the different services that would run on the user side.
But that's like more for the overall okay, that's not bad. The answer I was looking for was actually the API itself.
Okay.
Do you understand why I might lean towards there?
Yeah, how is this going to communicate with the actual system, basically?
Right. It's like, hey, you say you're going to upload diffs, right? Well, what exactly does that entail? What are you going to put in like the file version, the hash, or are we going to have like some explicit versioning of it? And like if we have versioning, right? Do we want to have the metadata of all the files, like version 20, 30, 40, in the uploaded as part of the client, or do we just want to run by file hashes, right? And last time changed and whatever, and then we associate the diff, right? The diff might be incredibly big. You know, how do we want to handle that API? It's not an easy one to answer for sure. but it's at least a question that I think is the most logical one that they'll jump to.
Yeah.
Okay.
Great.
So again, it's not bad because no, they do actually, because implicit in that actually, like if you look at the section 5 here, let me bring it up. 5A client, right? This is what you're talking about: upload, download files, handle file change, handle conflicts. Yeah, implicit in that is the conflicts, right? What does the API do? How should we respond? And also transfer files efficiently.
Mm-hmm.
Yeah, the API. That's implicit if I think about like what the next logical question is, right? If I think about the API, how does this actually all get uploaded? Oh, what if even I said it. It's like, what if we have a really big diff?
Mm-hmm.
So.
Yep.
Yeah. So it's like that chain of logic. If I start pulling that thread, and just like say, hey, this is a little vague. Let's go into the details, and then what the logical follow up to that is. You eventually get here. Oh yeah, they even call out keep a local copy of the metadata. It's literally exactly what I just said. Should we keep the version of it or not? How can clients efficiently listen to changes happening on servers? This is probably like they use long polling? Okay, shit. Okay, so they actually do go deep into like the client internal database. Okay, that's fine. So they actually do go deep into the client stuff. All right. Okay, and then they also have like slow servers and mobile clients remote sync changes. Okay. So in other words, they do actually dive quite deep into the client side of things.
Yeah.
Okay, so the way I would think about this, and I don't know if you call it out, is like what is the responsibility on? Well, first of all, is the client responsibility in all this very relevant? Is it important? So the answer probably is yes, because hey, there's like some syncing that needs to go on, right? And syncing is a responsibility of the client. That's one way to logically think about it. Like, is this important? So yeah. So we go back to functional requirements. Yeah, okay, that's fine. Because versioning is very, very fucking hard. So, and that's going to be a client. The client needs to update the server of like what version of new files are happening. So that's one way to think about it. Okay. So, and all we did was just follow the. This is what's important. This was not. Okay, fine. Now let's see what you do next. You're uploading file, relieve strand of the online database. Set a complete file checker to set out awful changes. Move off chunks to chunk ID a data store. We would never want to lose data. We'll have to introduce replication to avoid single point of failure. Okay, that next question is like, now that you say replication, what's the next logical thing? What's the next logical question you should answer?
For replication, okay, since we only we'll have to introduce replication to avoid the single, right? Let me see. So in the diagram, I did the set to database. Is that what you mean for the next step? Or?
No. So you say you want to replicate the servers, right? But in that regard, go ahead.
The databases, yeah.
Are you talking about the metadata?
Yes.
Okay. I see.
The metadata and the database that stores the chunks of the file text, file content.
Give me a moment to think. Okay. That's fine. So you want to be able to start replicating things. In other words, you're gonna need to have some kind of policy where, okay, well, do we want to partition the data? And then eventually they go into metadata partitioning. Actually, oh shit, they actually do. Because when I'm thinking about this, I'm like thinking, okay, if I'm copying the metadata, creating a bunch of make copies of it, I'm like, okay. Well, if the user's like uploading, and then you eventually, because you chose consistency, availability, and partitioning, eventually some of these are going to go down, and you're getting inconsistent data, and eventually when things come back up, how do you resolve consensus? Because I have version 9 on one metadata and version 10 on the other.
You know? Yeah, this is where you...
Go ahead.
Yeah, this is where you have to do some sort of sync service that handles all that.
Okay. Yeah, so you're gonna have like some deduplication or some shit, right?
Yeah. And they mentioned that in the key as well.
Do they? Oh shit. All right, yeah. I know this discussion is getting a little bit hairy, but this is the way I would have logically thought about it. I would have just thought of it from the end user. Start with the client, then follow the way based on the way the client is uploading these things. How does it affect things on the server? Just based on end user interaction. That's my only engine here.
Okay.
So okay. So did you handle deduplication here? No, I don't see.
No,
I don't see you call it out. Okay, so that's gonna be something you want to put into your what you did right, what you did wrong. Partitioning tables. That's gonna also be something you're gonna want to do. I don't think you call that out. Actually, I think from here it looks pretty light. Okay, but you at least have some hashing going on. Okay, shard based on ID plus number of servers. Can I guarantee universal? Okay, I introduced a key percent of the servers. Mouse key. Okay, so you use the key generation service. Okay.
Correct, yeah. Yeah, so I remember from the previous chapter that they said, okay, if you shard based on the ID, on the user ID, you can have a user that's most popular than others. So what they do is, okay, let's shard it on the file ID, and there you can distribute your files among all the servers.
Okay, so the cool thing is that how would you use the key? There has to be some link between the key generation service and what shard the thing lives on, right? So that would be an implicit part of the discussion. You could do the key I don't mind the key generation service, but I think the shard-based ID plus number of servers is going to be important, because what happens if the number of servers, or I should say number of shards, change?
Oh, yeah.
Yeah, because like, oh, we have too many files. And also, implicit in that is like, well, actually, if you design it with like a file store, and then you have like the metadata, and then you shard that, and then let's say number of servers and shards change, it's gonna be harder. So this is kind of a weak discussion. I would definitely want to go back. I would look at the metadata partitioning section actually. I think it seems incomplete.
Okay.
For the sync, okay. So in other words, I think you got through half the problem in a not bad way. And I'm going to skim through this. Okay. We still have the issue of uploading a new file. Oh, this is your second run at it. Okay.
Yeah, this is after reading the answer there.
Step responsibilities, good. Okay. Diff checker, what's the term by it? Given that the user expects to have high availability and never losing data, we need to isolate single points of failure. Okay. This is fine. Based on the second run, let me ask you, did you memorize the answer, or did you actually come up with a better approach?
So all the questions I had to come up with this, like for example, on the first iteration, okay, we're gonna let the user upload this. So every thought or comment that I had, I wrote it down, and then I basically added there, separating the databases.
Okay.
But yeah, I would say it was a mixture of memory and writing down those questions.
Okay.
Because it wasn't fresh on my mind. So.
Okay, I'm gonna say that the memorizing things is very dangerous, right? So I would like the whole discussion I had of like, oh, here's all the tools I'm using to try and consider the problem. I would want you to at least write those down in your checklist. That's the thing, and then be able to throw that at the problem holistically. If I threw this remember the thing I mentioned at the beginning. If I gave my checklist to someone who didn't memorize the problem or whatever, like a senior engineer, could they reasonably come up with a good solution similar to what you got? Okay. Other than that, the second run looks a whole lot better, and your reasoning looks a whole lot cleaner. So then now let me look at your Delta. Improve. You have multiple devices. Use a client to reduce errors. The heck? What the heck does that mean? Hold up. Let me delete. Actually, let me write this here. If you have multiple use client, reduce errors.
Well, yeah. So my thing there is, I had I had arrows for like a mobile device, and I had arrows for like someone on the web. So that just got confusing. So in the future, I'm just gonna have like a box or a cloud that points to the servers and indicate that it's multiple users and devices.
I think the general principle you should draw out is draw boundaries around like the different components that have responsibilities. So, for instance, if the client is
Mm-hmm.
responsible for X, Y, Z, which is like the diff, the versioning, and whatever, you want to draw a boundary around each one of those responsibilities. I think that's the general thing you should take away from this. So, back to single responsibility principle. Principle
Okay.
equals boundaries. That's the way I would describe it.
Mhm.
So, okay, let's look at the delta here. Okay, approach, enable, entailed low bound. Am I looking at the right one? Wait, did I copy the right one?
No, that's Instagram.
That's Instagram one. My bad. I fucked up. Okay, let me pull it up again. Okay. CP versus Dropbox. Delta was close to a 3 servers, however, missed part of the backsync to the user. Yeah. So how can I do one thing and one thing only? Good. How do these fluxes change on my design? Okay, it's safe to assume that we don't need 2 services for file handling. My mistake. I don't know. Let's rewind that. Why do you feel that's a mistake?
Are you in the prep doc here?
I'm in the prep doc, yes. I'm reading safe to assume we don't need 2 services. My question to you is, why do you feel like that was a mistake?
Safe to assume we don't need 2 services. Oh, okay, yeah. Yeah, I wrote this wrong. So my reasoning for saying that is based on the previous problem from Instagram, they just did one box for like the upload and download. So there, I said, okay, if you're gonna upload files to Dropbox and download files from Dropbox, just have a file server, for example, or block server, whatever you want to call it. But we do need a service to handle this these files.
I wouldn't say. I think that having a separate read write is actually not a mistake necessarily. In and of itself, it's that I think the reasoning behind it might have been weak. And I can see 2 factors.
Okay.
One is that you're used to like the 100 reads versus 1 write. That might be one reason that you kind of just like did that automatically. I think it just might be some habit. The other thing might be, oh yeah, it might be unique to Dropbox itself. I'd have to do the problem. Is that, well, you're not going to read or write as often, or you're going to do it in chunks. So you might not need to care to separate them because the relative level of traffic, like separate requests, are going to be low, but the volume might be high. So for instance, let's say that I'm working with someone in a workspace, and then they upload a 30 megabyte file. And we chunk 30 gigabyte file, and then this chunked up into 4 megabytes, right? Now, there's not going to be like 100 users trying to sync that file necessarily. It's more like maybe 1 or 2 other devices that get that file.
Right.
So that changes the dynamic. So you might be able to get away with that. That's the thing. I would have to do the problem myself in order for me to really understand it, but those are the first 2 things that come to my mind. Let me see if the book itself gives an answer. Like, why did they stuff it into 1 service? That's my question. Maybe it's like, let's see.
Yeah. What I was thinking is like, okay, this is a really complicated system. We're gonna separate this out into like the client. So that was my idea on why they did it that way. Maybe you have a different reasoning there. From a very high level, it's just gonna be 1 box, right? But if you zoom in more, it's gonna be two services or 2 APIs, whatever you want to call it.
Yeah, that's what I'm saying. It might not be a mistake. Maybe the book said, "Hey, that's not the most important part."
Okay.
So drawing a box around the things that is not most important, and then you can dive into later, that's perfectly fine. And I think based on the discussion and what we just saw here, being able to just handle the synchronization, upload, download, and whatever, the handle synchronization and the diffs and everything seems to be the main bread and butter of this problem. So
Yeah.
Again,
Yep.
what you did is not necessarily a mistake. It's just not the most relevant. That's it.
Okay. Okay. Okay.
That's the way I would think about it. So block server upload download. That's fine because again, being able to separate upload and download is not the most important part of the problem. Being able to sync the files is the most important part. So that's fine.
Mhm.
Questions completely want deep dive. Is it obvious to the person reading it? Yes. This actually should be part of your checklist. I would
Okay.
argue
Okay.
because it's very important that and you might have seen me talk about this in previous streams. Is that if someone with no idea what the fuck's going on walks into the room, they should automatically understand what the hell you're doing.
Yeah. Yeah.
Rules playing by desktop and mobile clients. I don't think this is as big a problem as you think it is. Because fundamentally, if we think about the difference between like a laptop, between like a computer and a mobile client, the mobile client just might be on a 3G network, so
Mhm.
what that
Mhm.
comes with is that hey, yeah, for over the air stuff, they may have their billings changed based on how much data they consume, right? So that's
Yeah,
gonna
yeah.
be like, now the way that would affect us is if we want to enable syncing over like over the air.
Yeah. Yeah.
That's would
Okay. Okay. Yeah. Yeah. Yeah.
so,
Okay. So, or you can put it to like the user, right? If you want data, click the pen to refresh, right?
I guess that's probably one way to think
Says-
about it. I would say this is not as relevant or as important. I would wager that the
Okay.
answer only gives like a one paragraph or one line shout out to the mobile client because it's not as important. Like if we think about the user
Mhm.
expectations, right? Is it really important that I am able to sync like very very quickly the very large files on Dropbox on my phone?
No.
Compared to
It depends, but no, not really.
it might be important, but there's probably a whole lot more important things. I think at most,
Mhm.
an end user would just want to see that the file exists. So in which case, we would only care about the metadata of the file, not the file itself. Like
Okay.
again, like let's throw the user at this problem. Would a user normally download a 2 GB file from their Dropbox? Probably not.
Mhm.
So let's look for mobile here. Mobile. Should mobile sync remote changes immediately? Unlike desktop or web clients, mobile clients usually sync on demand to save user bandwidth and space. Okay.
Mhm.
So
Okay.
literally, just kind of imagining how the end user would expect from mobile is it's already answered this question. So you saw like I was able to reason that out.
Yeah. Yeah.
So in other words, I don't think this is as big a role as you think it is, but it's a question definitely worth considering.
Okay.
Will files be retrieved over and over again? Cache restraint. Yeah, I mean that's the whole purpose of a cache, right? You don't want to make repeated requests to the database. Well, let me see how the book handles caching. Okay, introduce hot chunks. Okay, memcache is for whole chunks with its respective IDs and hash before putting the block in the store. I would say the discussion of what's called memcache. High-end commercial servers 101. LRU. Okay, they give kind of like a service level nod to it because most of your discussion is going to be being able to handle the syncing, and because that's the most important part, right? And then how that affects the database. The caching is kind of like is secondary to that. So I understand why their discussion of this is kind of light.
Okay. Okay.
So it's not wrong. Again, it's not really a mistake. I think it's just more of a question of what you spend most of your time focusing on because what is more important. So.
Yeah. Yeah. This is like the load balancer, right? Like we can visit that at the very end, right?
Yeah, because it's not as central to the problem. So this is not this is
Okay.
not a bad question to ask, but I think that there are more pressing things that you could have asked yourself and focused on it. That's at least my impression. Second, define the client-side workers, misconnection to block store. Don't you mean block store? Is that blob? Is that a blob store?
It's connection to the cluster. Let me see.
Okay, this is. Let me see what the book. Yeah, it is blob store.
Yeah.
Cloud block store. Okay.
Yeah. So those red arrows, those are the points I mentioned there on
Got
the
it.
top.
I see. I think something that I might have missed is that they don't actually keep the files sequentially. I think they just say, here's, in their storage, they do like, here's chunk 1 out of 100 on this storage, chunk 2 out of 200 or something like that. I think that's the way they're doing it because, if you're uploading a diff, you don't affect the entire file. You only affect a chunk of the file, so you only have to update those chunks. I think that's basically what they're going for here.
Yeah, exactly.
Got it. That's fine. Client misconnection to block store. Yeah. So if you have that idea in there, then you do need to understand like okay, individual workers go for maybe modifying one particular chunk. Okay, that's fine.
Mhm.
Block servers will work with the client to upload download files. Yeah, sure, sure. Rather than handling logic on client side database, want to create a single service. I don't understand that. What do you mean? Hello?
You see, yeah. Rather than handling logic on client side or DB side. Yeah. Let me see. Yeah, I think that I'm a little confused there too, but it's essentially saying like, what do you want these arrows to point to? Like, because I miss pointing to the block storage and to the sync service there.
Okay. Usually when I see someone make a mistake like that, it usually means that they don't have a good high level design or understand like the way these place things fit into each other. So let me go ahead and open up the Excalibur again. Give me a second. So like if I compare the way you're doing this versus like the way the book does it, yeah, the second time you notice they actually start off with the block server, metadata server, sync server, right? In order to kind of define these responsibilities. I think that you may have missed out on your second run. Let me see. No, I think you got it. Yeah. No, you got it. So what the hell happened? Why did you?
Yeah, man, I probably copied and pasted that from earlier entry. Yeah, because it's confusing to me right now.
Yeah, I don't understand. You're gonna need to clarify that because when I look at the what's it called, if you look at the book, they did like you did. They just block server, metadata server, synchronization server, and client. If you just declared like what responsibility each of these had, then I think it would have made your life a whole lot easier. So, for instance, what we would have declared in this problem is that the clients are responsible for determining what chunks and differences we want to upload, right? To the block server. And the block server would manage, hey, yeah, this is where we upload chunk, 1 out of 10, 2 out of 10, 3 out of 10. And then we also write that to the metadata storage. And then the metadata server would be responsible for querying those new updates and metadatas and then going to synchronization. And then synchronization is just responsible for making those feedbacks to other clients. If you had declared that those responsibilities at the beginning, I think it would have divvied out your work. And then the way you could have approached it is, okay, now that I know what each responsibility is, I can immediately go into each one of those individual components because I know what the responsibilities are. And the most important one, just based on that, would be the clients. Then you would be able to do the problem the same way that Grokking did. I think that's you might have missed that explicitly actually. So if you explicitly declare what your high level components are and what the responsibilities are, then you go from there to say, hey, yeah, which was the most important thing. That would have started you off on the right track. I think that's what you really meant. So what will client interact with? Yeah. Other than that, I think I like the direction you're going in. Definitely just be able to dig a little bit deeper into why these things happen and what principles you can draw out, not just for this particular problem, but for the next problem.
Okay.
All right. With that, let's actually go ahead and do a problem. So I'm in your problem sheet right now. Oh, by the way, did you get a chance to do like any what's it called LeetCode?
No, I just stuck to the system design.
Okay, that's fine.
Yeah, I should do some tomorrow or Thursday.
Probably, because again, there was that little bit of you did kind of screw up quite a bit. So I'm keeping an eye on that. I would recommend you at least do some this weekend, and then we can at least do another problem of that next weekend. So let's go ahead and do a problem. And I want you to keep in mind just being able to go through things logically and start from a high level and just find single responsibility. Logic and single responsibility I think is the name of it. It's going to be your bread and butter, at least for now. So let's go ahead and pull up a problem. Oh yeah, let me just go through Excalibur. Damn it, right? Okay, we already did the like real time counter. Okay, yeah. Let's open up with Scaladraw. Give me a sec.
Okay.
And then I'll invite you to the thing. Okay, I'll send it to you in the chat. Can you see that?
Yep, I see it.
Okay, cool. Alright, and... Alright, here we go. So I want you to design a newsfeed system like Twitter, which should be very relevant to what you just did, so...
Okay, newsfeed system like Twitter. Okay, so let's start defining our requirements. Newsfeed user should be able to follow others. What else? User should be able to post to their timeline. What else? What else do I need? Do we want to support images for this one?
Yeah, sure, why not?
Okay.
Well, yeah, let's support it, but I want you to consider it as like a nice to have.
Okay. Couple of photos. What else?
Remember, we're basically mostly dealing with tweets here, so think of it in the context of Twitter.
Okay, so you can follow others, you can post your timeline.
Well, keep in mind, we're focusing only on the newsfeed, so.
Okay, only on newsfeed, okay. Newsfeed, newsfeed should low latency. Yeah, newsfeed should be low latency. We don't want it to take up a lot of time.
Okay.
What else? So, should.
Well, okay. So we're saying low latency. When you say newsfeed should be low latency, are you saying the request to get a newsfeed or to generate a newsfeed?
Oh yes. It should user getting newsfeed. User getting newsfeed should be fast.
Okay.
Let's see. System should be reliable. Should be reliable. What else? Low latency. It should be reliable.
And also, let's put a number to low latency.
Okay.
So let's say Kanye tweets. How long? What's the maximum time a user should wait to see the tweet?
It should be under a second. Let's say 200 milliseconds.
That's quite okay.
Or
I mean, it's not bad. Let's go through all the functional requirements and then let's see if this is actually going to be a number we want to play with.
Okay. Okay. Any system should be reliable. Let me see. Okay, so it should be reliable. What else? For the non-functional requirements, I'm having a brain freeze here. What else? So if this is going to be a high reach service.
Mm-hmm.
Going back to our last example, it'll be 100 to 1. Read write.
Okay.
For numbers, let's start off with like 500 million users, right?
Sure.
500 million users. Let's say they post 100 tweets a month. So
That's damn. You tweet more than Miley Cyrus if you do that.
yeah. So just to get like a rough estimate on the storage that you're gonna be playing with, the 500 million times 100. That's just looking at posts per month. Okay, so you're looking at 500 billion posts per month. For that system to scale, how much is a tweet gonna take up your space, right?
Sure. Let's.
Would it be?
Yeah, tweet's 140 characters, so let's say 140 bytes per. What would you say?
140 bytes, you said?
Well, yeah, because the character's a byte.
So what if we round it up to like 200, right?
Sure. Why not?
This is gonna have like all your other metadata, right? Like considering you're gonna add other data to your table, like latitude, longitude, who it was created by, etc.
Why not?
200
That's
bytes.
reasonable.
So that's gonna be. Two more zeros. Okay, so you're looking at okay, so how many bytes do I have here? So I have about a terabyte of data here. Come on.
Mega, giga, tera.
Oh
You
shit.
have a yottabyte.
Isn't it sorry,
Oh, no,
so it's
I missed kilo. You're right. It's terabyte. Kilo, mega, giga.
okay.
Kilo, mega, giga, tera. Yeah. All right. Okay. So one other thing.
So
what?
Mhm.
No, I was saying that.
Okay, so go ahead. Sorry.
I'm saying that. Okay. Well, now this is me speaking as a coach. Is there anything else you're missing?
You're talking about like the ingress and outgress?
No. For functional requirements and non-functional requirements, are you done, or is there more things you want to consider?
I wanted to say that based on this storage amount, you have to keep these tweets forever, right? Unless the user deletes them. So it's not like the URLs when you can delete them right after TTL.
Nope.
So these should live forever.
Okay.
Until the user deletes them. Okay, so given that, so that would be another non-functional. These should live forever until the user deletes them.
Okay.
Okay, you generate your newsfeed. Do we want to support like like counts? Because they have like counts, right, in Twitter?
Let's say instead of like counts, let's keep it simple for now. And let's make a user can like and share a tweet.
User can like or share a tweet. Okay. Okay, so it should be reliable. I still haven't talked about the CAP theorem. So it's another checklist. Here it's going to be on the web. It's partitioned by nature. Is it okay if the user does not see the tweet right away? Yes. I would say it's okay if they don't see a tweet like right away.
Okay.
So I would go with availability there.
Okay.
Let's see. So now I want to draw the simple solution that will satisfy some of these functional requirements.
Okay, so let's before we close out, are you saying that your functional and non-functional requirements are done?
Okay, so system should be reliable. Yeah, here you should live forever. As far as the functionality, I don't think I'm missing anything.
Okay.
Follow users, post to the timeline, getting someone's time, getting the newsfeed for a user.
Okay.
Users can like and share a tweet. Nice to have, upload photos.
Mm-hmm. I'm gonna let me help you out here a little bit because based on the numbers that you just gave, minimal latency on a 1 terabyte per month with 500 posts per month or whatever, a little bit difficult. Let's also not to mention when you said that things should be highly available. Well, what about the Kanye tweet? So in other words, you might get a high response, but it might not be fresh.
Right.
So, in other words, what you said isn't wrong. It's just very difficult. I'm going to help you out here and say I'll recognize this 100 milliseconds. Let's say, 2 to 5 seconds. Let's say that's what was told.
Okay.
Just to make our lives easier, because I guarantee you, if you do the actual stuff and you actually try to put it on it, you will have a very difficult time.
Mm-hmm.
So, otherwise, I think it looks fine. Let's keep going.
Okay. So here's a user server. This is gonna then we have to keep the data forever, so introduce a database here.
Okay.
Okay. So users should be able to follow others. For that, it's just a simple. I'll define some quick schema here. So
sure. Yeah, let's be fast about our schemas.
User follow. User 1, right? And user 2. You also have to save the tweet data. User ID, content, user, long,
sure,
etc. And also need the user table. Okay.
Sure. Okay. So now you have that. Now what?
Now that I have that is okay. So users can follow others. They can post to their timeline based on this tweet table. Getting the newsfeed is not okay. So you have a user. They're following 1,000 people. You're gonna hit the single instance of the server, and then you're gonna hit this single database. I see a big choke point here because you're gonna grab a bunch of users. You're gonna grab all the users that the user's following. You're gonna grab their top posts. Let me see. Okay, yeah, I didn't mention ranking in my function requirements. So let's kick that off a bit. You're gonna have to create a timeline or a newsfeed for the user. So not all users are gonna follow. not all users are going to follow many people.
Yep.
It's going to be all over the place.
Okay.
So but what about that one user that's following? I don't know what the limit is, 100,000 or 200,000.
Sure.
This is gonna be a big issue with your database here.
Okay.
So my thought on that is why don't you separate these into separate databases? For example, you can have a tweet database, user database, and user follow.
Okay.
You want these all living separately because are you really gonna do joins on, for example, users and the tweet, right? So let's separate this out to make it easier. This is a user. This is a tweet. Okay. So based on that, the tweet is just text, right? I'm thinking of does this really belong in an object store? It's just what 160 characters. It's just 160 characters, so we can get away with storing it in a simple database for now. Not mentioning technologies, but let's just keep it as is.
Sure.
As a single tweet, right?
Okay. So you have your tweet database, your user database. Fine. All right.
Mm-hmm.
Now what?
Okay. So now it brings me to the point of 1 second. A big inefficiency that we talked about in a previous point is that generating the newsfeed service for a user.
Mm-hmm.
So my idea is to move this out to the single responsibility, using the single responsibility principle, have some sort of service that can generate the timelines on a certain user. Mm-hmm. So I only care about tweets. This service can return me back tweet IDs. Later, they can get rendered somehow to the user. So for the most important thing is I want to introduce a newsfeed service that can grab all the tweets from the followers of a certain user.
Sure.
No, sorry. Yeah.
Okay.
You're gonna basically flood the newsfeed with people you're following.
Mm-hmm.
So this is the newsfeed service. Okay. So, what else? Going back to my functional requirements. Okay. User can like and share tweet. That's something I didn't talk about in the data schema. So I can say I can have a tweet that's like the user ID. That's the tweet ID mm-hmm. and who it was liked by, and the timestamp. Okay, so the newsfeed service. Let me write this down. Newsfeed service will be responsible to get the people user one is following. It is of tweets based on so it's just returning you tweets. Okay, yeah, this is where I'm getting stuck because you can have a newsfeed service, but you can also throw all these fancy algorithms on how to generate this timeline.
Okay.
But let me see. So let's see. It's an aggregation on tweets based on.
Okay. Remember, you're stuck. What's the way to get unstuck?
I would backtrack and I would backtrack and start talking about the newsfeed service again here. Going back to the functional requirements.
You're already in the newsfeed service, right?
Mm-hmm.
So why would you just go? You're just going back to the same place. So my question is, what? How do you? You're just going to stay in the same place. So my question is, what do you need to think about in order to get unstuck? Well, let me rephrase the question. What's blocking you?
What's blocking me is there's a bunch of there's more to it to just saying it's a news service, right?
Okay.
If you want to take a deep dive, how are you going to interleave all the different posts that you're going to get from the people you're following? Do you want to sort them by? Do you want to sort them by the timestamp? Do you want to sort them by the number of likes?
Uh-huh.
Do you want to sort them by the engagement between users? So I can say it's an aggregation of tweet.
Okay, so yeah, that's fine. It's fine that you consider all that. Now, next question: how important on a scale of 1 to 10? How important is this to design the system?
Okay, sign into Twitter.
Is it?
I would say.
Go ahead.
I would say it's not very important to talk about that because in our functional requirements we didn't define that. It's just basically getting posts from the look of it.
There you go. You're spending too much time on something that doesn't matter that much. I can change the scoring algorithm tomorrow to be instead of based on the user's follows, it could be the number of posts the user interacted with in the past 10 days and the people that they've interacted with. I could change the algorithm like that, and it would have no bearing on the system.
Okay.
So in other words, you're focusing on the wrong. You're focusing on something that doesn't matter.
Mm-hmm.
All right,
wait, cycles. Okay, so for that, it's just a simple interaction here. The newsfeed service will read from both the tweet table and the user follow table. Let's see. Yeah, so let me see. This is high level, going through his interaction. Okay, so I'm thinking, so you hit the application server first, right? Then there you can have like, okay, take me to my homepage and show me my newsfeed service. So the user should not point directly to the newsfeed service. It should come from the application server.
Mm-hmm.
So I have this. Okay, so they can follow their users. They can post to their timeline. User getting users should be fat. Okay, so this looking at the functional requirement, I'm seeing user getting users should be fast and minimal latency. What I want to do here is I want to pre-generate or I want to compose of some sort of, looking at the functional requirements, I want to grab active users, and I want to generate their timeline on the side. How can I, what's the word? I want to pre-generate their timeline.
Okay.
So from the functional, you see that the latency to get.
You don't need to write this part out. You can see it on the replay, but I get that this is part of like homework, but just treat this as a normal interview for now.
Okay, so given that the latency latency for getting a user newsfeed is quite low, 2 to 5 seconds. I want to pre-generate newsfeed for active users, for daily active users. People that don't log in as much, I don't care much about them.
Yep.
We can generate these on the fly or send some sort of message to the user your tweets are getting refreshed. Come back later. Okay.
That's weird. So
User-
why would you want to block a user from getting their what's it called, their tweets?
Yeah, that's a bad step there. My reasoning behind that was thinking of a service like GitHub where they have certain actions that tell you come back to the page and your results are ready. But since this is a service that's going to be fast for users and give them the most optimal experience,
Mm-hmm.
their newsfeed should be generated on the fly and right away.
Okay.
So
another way to think about this is that one of Twitter's value propositions is that it's basically real-time news, right? So the clients may read inconsistent data, but if it's off by like 2 to 5 seconds, probably not that big a deal. But if some data doesn't become unavailable, then we have a bit of a problem. And that's kind of why you picked AP over CP.
correct.
So
Okay, so based on our discussion where we have an AP system, you essentially want to introduce some sort of cache, right?
okay.
You want to retrieve data for the user as fast as possible. A caching is going to be much faster than looking into separate databases. So why don't we take the approach and say let's use the 80-20 rule, right? Where 20% of the tweets will account for 80% of the traffic.
Sure.
So I will. My idea here is to introduce a cache to provide these tweets to the user in a fast manner.
Sure. So how are you going to populate the cache?
Okay, so I want to populate the cache by using the LRU principle. You grab an item and then you post them to the cache. You're going to have a certain fixed size in your cache, so the oldest element in your cache is going to get popped off. But if you take into account popular celebrities, if I take into account celebrities, then it's a different scenario I have to take into account.
Sure. Yeah, go ahead.
Yeah, so I know a couple sessions back we talked about a fan out for popular users. So if you see that a user is following someone really popular or they have multiple celebrities on their page, why not create a cache? Why don't we always keep that data in cache? Because it's going to be consumed by many people. So there's not a lot of celebrities. My reason behind this is there's not a lot of celebrities compared to everyday folks, right?
Okay.
So why not keep separate caches for really hot users?
Okay.
Because from what I get from Twitter is it's very popular amongst celebrities. Mm-hmm. So having those tweets in a cache, it's gonna save a lot of strain on our system because you're talking about people with millions and millions of followers. Mm-hmm. So you essentially want to cache that compared to like users that aren't that popular.
Right. You're basically talking about a fan out policy, or fan in.
Correct.
Fan in versus fan out, right? I always forget which one's which, but yeah. I think it's fan out. Yeah.
Mm-hmm. So let me separate this out a bit. So for the cache, it would have to live between our databases, right? As far as the fan out, for that, let me see. I don't see a diagram for that. So for those type of caches, is it just a separate cache that you want on the diagram, or
just keep
do you want
you consider this diagram as a living product?
Okay. Okay, so most importantly, I'll explicitly state we have the fan out cache here. Okay.
Wait, I don't see, are you typing? I don't see anything.
Right here.
Wait, hold on.
Fan out cache for celebs.
Wait, let me go ahead and... Hold on, I'm reloading the page. Okay, got it. Cool.
Okay. Okay, so you should be able to follow others. You should post your timeline. Okay, I didn't get to the timeline yet, posting to the timeline. Also the like service as well. I'm thinking of doing a like service.
Don't worry about the like. You still
I mean, you can...
don't worry about the like for now. Right now you still want to do the right post, right tweet and retweet. Where retweet is just really the not retweet but read tweet, which is the news service. Keep in mind you still need to do the news service.
This is a posting to Twitter, right? That's what you mean by that?
Yeah. So there's two interactions, right? One of them is, hey, let me aggregate the tweets to create a news feed for someone, right? On the other side of that transaction is that someone needs to also be able to write those tweets. So my question to you is, you kind of handle the read part, but my question now is like, what about the write part?
Right. Okay. Yeah.
Or maybe
based on our
I
discussion,
didn't quite get it. So yeah, go ahead.
Yeah, based on our discussion, you mentioned it would be real time.
Yes. Well, near real time, yeah.
So near real time. So I'm gonna post. Let me see. So I want a separate service for this. Just for the sake of simplicity and simple responsibility. Let's say this is our post tweet, right?
Okay.
So the responsibility of a post tweet is to grab your text and save it into our databases. So here I'm thinking of all the millions of people that are going to be tweeting. A celebrity can tweet, and then that can write it to the cache, and then to the tweet table. A normal person can post the tweet, and then that can get saved to the cache, and then saved to the tweet table. Using a cache that can evict the oldest entries. So now I'm thinking of how can we post these tweets as fast as possible. You can have various APIs that can handle large number of requests, or you can have some sort of messaging queue. So my argument for the messaging queue, okay, you can send it off to your queuing system. Then there can be some sort of a tweet ingester that saves it to the database.
Is this for the right path or the read path? Because I'm not quite sure I follow right now.
For the right path.
Okay. You know what? Let me
so
stop.
Right now,
I'm going to stop it here just for the sake of time, but I think you're on the right track because you're 30 minutes in, by the way.
Okay.
All right. Cool. Tell me what you think you did right, what you think you did wrong.
What I did right is we started off simple. What I did wrong was falling into the pit where we didn't need this. For example, for the newsfeed service, I was talking about different algorithms and whatnot, and that wasn't part of the functional requirements. So I think I kind of got stuck and kind of got a brain freeze there.
Yep.
Or just a mental stuck state.
I would say that you didn't really focus on what was important. So I kind of mentioned this before, right? These are my notes, but I would say that you did okay with the functional non-functional requirements. I only helped you out with the latency because I'm like, you need to get a sense of what these numbers mean. It's one thing to do the calculations for the numbers, right? It's another thing to know, like, hey, based on these numbers, here's where, like, shit might fuck up, right? And this is why I might have to start making negotiations. In this case, the latency is going to be pretty hard. Why? Because, well, you already said that you're going to have, 500 million posts per month. That's quite a bit, you know? And so because of that, being able to generate data from 500 million new posts per month, or like on a second by second basis, is very, very difficult. So it's like understanding what the numbers mean. Like it's like that Modern Warfare, was it the Call of Duty Cold War, whatever, Modern Warfare, like what do the numbers mean, Mason, like sort of thing. So
yeah, Black Ops.
Yeah, Black Ops, man, I haven't played that game in forever. Jesus. I'm glad you reminded me. But okay. So the next part is, now that you kind of did that, and you need to prioritize what is important and what is not. If the whole point of a newsfeed is to be able to read the tweets that other people have created, then it becomes very obvious that you need to also handle the tweets people have written, right? So the first thing I would have done is be able to handle like the read path and then the write path. At least that's what is obvious to me, because being able to retrieve the tweets and whatnot is like super, super important. So in other words, where am I going with this, right? What I would want to do is to be able to write that in a user story. And I think we mentioned this before. Like, not just the user expectations, but how might the user actually go through the system. So this is like a little bit where like an API design may or may not come in handy, although I would probably skip it because it's a little bit stupid, because like all it really is like user gets home timeline, right? And then backend creates a newsfeed service for them, right? And then you might want to go into that. That's the read part, and then the write part would be the user tweets, and then be able to get some confirmation, right? That's a very stupid thing, but if you think about what those entail, it becomes a lot more complicated. So like on the back end, what does it mean for us to generate the news service? And this is where you kind of go into like the read and write stuff, which I don't have a problem with, like the fan in fan out policy, right? But you have to also consider that for the fan out cache, which is what you did. Oh yeah, celebrities might be hot when they tweet, right? And then for normal users, well, we want to do a fan in because, well, when they tweet, not many people are listening to them. So I don't mind this cache thing. It's a little bit hard though, because now you have to start managing. Oh, how do I know this person's in cache A versus cache B?
Yeah,
that's a little bit difficult. So I would rather just keep it simple. So to me, this screams too hard. At least that's for me, because are we going by number of followers? Because let's say our cap is like 1 million. So what happens if someone unfollows like a micro celebrity, and then like that number drops to 900,999? Do we just go to the new cache now? Does that necessarily change the calculation for the fan in versus fan out? I don't know. It's hard, and that's why I would avoid hard problems. I'm just gonna box it in one cache for now. And just say, hey, for these users, I will fan out. These users, I'll fan in. I don't know what the algorithm is, but I know we're gonna have something. That's basically because if I change that algorithm of like maybe I change the threshold from 1 million to 3 million, doesn't really fucking change the system. So that's kind of my point here. So and this kind of plays into like, oh yeah, you got really, really deep into like the news feed service algorithm. Again, if I change the news feed service algorithm and what the actual algorithm underneath is, it doesn't fucking matter. It doesn't change the system. So
yeah.
All right, and then but I would have liked.
Yeah.
Sorry, go ahead.
Yeah, I think I missed because it's a part of my functional requirement. I think I missed that because I went too deep into the newsfeed algorithm there.
If it's like too hard or not critical, then don't go there until you need to.
Okay.
That's really it. As far as your logic for the database is fine, right? Like you recognize, oh, if I stuff everything in one database into a bunch of different tables and then I scale it out, it's kind of shit. Although I would say that eventually you'll get to a point where you don't need to even entertain that. You can just literally just say it right off the top of your head because it's very obvious. But for now, it's okay as a crutch. So you have user tweet, user follows, right? And based on like everything that says here, I would even go one step further and say, hey, yeah, if I want to go SQL versus NoSQL, I would just say my user follows is very obviously some kind of graph database. My tweets are going to be some kind of SQL relational database, and then users as well, because eventually I'm going to have to join user and tweets. So I might actually want to have some kind of relational join, maybe not, I don't know, but it's fine for now. At some level, I would want to take that step because I'm very confident that while these may or may not live in the same database, although most likely not, they're at least some kind. I can declare that very safely they're a SQL database. next thing.
Okay.
So now, like, okay, now we have like some fan out service that will write to the cache, on the whenever we have like the hot celebrities tweeting, right? I have no problem with you putting a cache in front of the user's tweet and user follows as well. Although I know that this was mostly for tweets. I don't mind caching everything because if a user is very active on Twitter, even though they might not have a lot of activity, they might have enough followers. They might have a lot of friends, right? And so you might want to cache those users as well. Just for the sake of that one highly active user. Just some food for thought, something to reason about. Because if we follow the end-to-end thing, like, oh, user is reading, they might constantly be retrieving end user data, which means that now we can also even add users should be able to click into a tweet and go to another user. That might be a very hot path to follow as well, because very often when you look at someone's tweet, you're either going to reply to them or look at their details or go to their profile. I think that's not bad to go back into the functional requirements and add as a nice to have. But it unlocks that just based out of our discussion, right? So, okay, so now you have that. Let's say we progress through the problem. All right, now we want to be able to say, okay, let's start adding our nice to have, like the upload photo, download photo. The tweets would then have in your schema you have the content, right? Which is effectively just a URL. And then you can start talking you can say, hey, we're going to have a CDN here. And then web server as well. Like, once we start throwing a bunch of people at the server, we're going to have some problems, right? So now, because the application server is stateless, we can start putting a load balancer in front of it. And then we might also want to rate limit people from spam tweeting. Again, it's like the Kanye problem. If Kanye fucking tweets or Instagram posts 40 times in an hour, we might want to rate limit him.
Yeah.
Or I don't know if you followed what he wrote about Adidas and Gap. Oh shit, this motherfucker is writing some shit we don't really agree with terms and policies. Let's rate limit him.
Yeah.
I like calling it the Kanye problem. It sticks out in your mind, but it's a real problem. These are real things that the system has to deal with, right? So, I always want you to think about the Kanye problem. I always want you to think about the Kanye problem. If Kanye went on your service and lost his fucking mind, what would happen? Don't get me wrong, we love
interactions.
Yeah, don't get me wrong. I like Kanye, but some of the shit he does, my God.
Yeah.
So anyway, that's my feedback to you. I really want you to focus on what's important and what can go wrong. If you can use that as your north compass and especially what the end user might do, I think you're gonna do very well. But I would also encourage you to try to think about a little bit, probably not this week, but next week. Think about how you can get faster.
Okay.
Because a lot of these discussions that you're having, like with the LRU cache, it's very obvious it's not gonna work. It's not going to scale out. So in which case, if I'm the interviewer and you do this in front of me, I'm going to be thinking why the fuck are you doing this? Obviously, it's a very obvious thing that can be avoided. But there's things that are not obvious, but you need to be able to have this discussion. I'm only making you do this just so that way you can actually have that muscle in case the interviewer says, I don't know what the fuck you're talking about, where this is coming from. You can rewind a little bit and says, oh yeah, our naive solution is the LRU cache, but because we have the celebrity problem, then and the disproportionate number of users problem, we can then change it to this. That's fine, but you need to be able to do that. But so it's starting to get that muscle of what's important, what is not.
Okay.
Other than that, I'm not disappointed in what you did. I just need you to be a little bit more faster in tune. But I'm seeing some good progress, so you're on the right track.
Cool, awesome, man.
All right. Any final questions? I want you to I just want to keep doing what you're doing, but remember to add in the question to bulletproof your approach and clean up what we talked about before.
Okay, so basically how your doctor notes, right? Step by step, someone can read this and solve the problem.
Yes.
Okay, sounds good. Awesome, man.
No other questions?
Yeah. So one last thing is, you're talking about the load balancer and the CDN. So
yes.
Also, the replication, sharding, whatnot. That's one of the last steps you want to talk about too, right?
Yeah, you might want to, depending on where the pain point is. So let's go back to jump back in the interview and say, hey, yeah, well, these tweets might need to be sharded because we are gonna have a whole bunch of tweets. Because like you mentioned, some of these tweets that are really really old we want to keep, but these might not necessarily be the tweets we want to present, because how many people go back in time, from 5 years ago and look up Jack Dorsey's tweets?
Yeah.
Not a lot,
Yeah,
so we can put those in cold storage and accept a longer latency to retrieve them. In which case, okay, well, in that case, we might not need to shard it because, again, not many people are going to access it. So instead, we can have some migration service with that, if tweets are older than, let's say, 6 months, we will start moving tweets out of a hot database and then put it into cold storage.
Okay. Okay.
So then now we have a second layer of databases, if it really comes down to that. But I would argue in the context of this, we would still be dealing with the news service first. And then
Okay.
this would be more of a if there is time question. Because I was just thinking about from the what is relevant to the problem and what is important, the hot tweet versus the cold tweet, like the old and versus new tweets, not as important compared to just being able to get this shit working to begin with.
Okay. Okay. One last question is for the DDIA. You said you just reference that for some topics. Because I got that book the other day. It's pretty dense.
Yes.
So basically, for all these topics I understand, just do a quick read on it. Because I tried looking up like CDN or one of those topics, and it wasn't there. So
Okay.
I just resorted to simple Google searches. So
That's fine. Usually DDIA is mostly regarding around databases and the internal guts. CDN is just a nice to have. Think of it like oh, I'm going to throw Amazon at a problem. You know, and generally that solves the shit, right? But it's important to know how these mechanics work, especially for sharding, because these are like one of the, like, you know, leader versus leaderless and knowing those trade-offs as well. Especially when you have to dive into a database, it's really important to have that discussion and know like what the trade-offs are. And so when you I kind of saw you have this little problem like, oh, I don't know, I'm going to shard it, but shard it by what? Why? And what policy are you going to use for replication? You know, that's where DDIA comes into handy. And I'll tell you, I read a lot. I cannot read more than 20 pages of DDIA.
Yeah.
In a single day. So the way I see it is, if you run into a portion that I don't know jack shit about this, I am going to go into that section of DDIA, read it, and try to apply it to my problem. That's the easiest way to learn DDIA, in my opinion.
Okay. So if you're talking about sharding, when you're talking to the interviewer, do you want to say, okay, do you want to say the trade-offs first and then go to your actual solution, or do you just go to your final solution there?
The more obvious the solution should be, the quicker you want to get to it. So, in other words, if it's not clear and you need to work it out, talk the trade-offs before you commit to it. But if it's so obvious that you don't need to do it, then go to it, right? Like this LRU thing versus the celebrity problem. It's very obvious that you have the celebrity problem. So the LRU cache is a meaningless conversation to have. On the other hand, if we want the tweets to have a leader versus leaderless election to it, then that's a more nuanced discussion that we may want to work out ourselves.
Okay, that makes sense. Okay.
So the less clear it is, the more you want to consider.
Okay, cool.
All right. Anything else?
Cool. Awesome, man.
Good. All right.
Cool.
Keep up the progress, man, and remember to like review your mistakes and grind on everything. Yeah, you're making good progress. Okay,
so for the homework for replay analysis, another problem like last time?
Yes, another problem, another grokking one, and harping on your mistakes, and yeah.
Okay, awesome. So sounds good. Thanks, man.
All right, thank you. All right, later.
Cool. See ya. Bye.
Any final questions from the crowd? Anything that I said that wasn't really clear? Because I know some of the stuff about the captain I might have, like, you know, screwed up some details or might not have been clear, but you know, it's hopefully you guys get the idea. Let's see.
The Sport Clips MVP haircutting.
Oh no! Please, guys, do not ever get your haircut as Sports Clips, please. I don't think it's they don't do a really good job, man. I'll tell you this: if you find someone who cuts your hair well, stick with them and tip them well. The commercial stuff is not exactly the greatest, at least in my opinion. But I will say the hot towel on anything, if you're going to a spa or whatever, it's great. That's what this guy does. Alright, guess I'll shut down the stream. Alright, see you guys on Thursday. Yeah, 8 p.m. Pacific Standard Time.